Welcome YouTubers to another episode in my Grammar Hero series. In today's video, I'm going to work on some very simple questions that should mirror what you'll see in the very beginning of both the mathematics knowledge as well as the arithmetic reasoning subtest of the ASVAB. Again, the ASVAB is a computer adaptive test, which means that the first questions you're going to see, regardless of how good you may be at math, are going to be very simple and straightforward. In order to score very high on the ASVAB, you have to get those first few questions correct in order to get to the more challenging questions. And in light of that, I thought it would be a good idea to make a video showing you what some of those very simple questions could look like. As always, you're not permitted to use a calculator or a reference sheet on the ASVAB. So as you attempt these practice problems on your own, try not to make use of any of those resources. Likewise, I want to stress this over and over again. In order to get the most out of this video, you should attempt to work out all these problems on your own. That is to say, after I read a question, you should pause the video, attempt to work out the question on your own, and then resume playing the video to check your solution. As always, I'm going to include timestamps in the description of this video. Next to the timestamp is going to be the topic that this question's testing, as well as a link to a video in which I discuss that topic in greater detail. So if for whatever reason you feel as if you need more help with a certain topic, check out the description of this video. There you'll find those additional resources. So all those things finally being said, let's go ahead and get started with today's video. All right, this first question says, which of the following fractions is equal to 0.06? In other words, we have to take 0.06, a decimal, and rewrite it as a fraction. So in case you haven't done that in a while, you may be lost as to how you get started. Let me just say this. A lot of people can do this one mentally, which is great. That's not the scope of this video. This is to really help people who really need to relearn the fundamentals. So let's say I asked you to write 5 as a fraction. How would you go about doing that? Well, if you haven't worked with fractions in a while, you may not recall that to write any number as a fraction, you simply place it over 1. So in other words, 5 written as a fraction is the same as 5 over 1. If you think about this, 5 divided by 1 is just 5. Again, anything divided by 1 is just itself. So that's the approach we're going to take to this one. We're going to take 0.06 and write it as a fraction by placing it over 1. That said, if we look through our answer choices, we can see none of them match this. And the reason why is we have this decimal right here. So our next task is to clear this decimal. And that's actually pretty easy to do. We're going to take 0.06 and multiply it by 100, which will clear this decimal, as you'll see in just a second. But to keep proportionality, we're going to have to do the same thing to the denominator. So let's start with the simple math. 1 times 100 is 100. Let's think about how we're going to do 0.06 times 100. Whenever you multiply a decimal by a power of 10, such as 10, 100, 1000, 10,000, and so on, you simply take the decimal and you shift it to the right according to how many zeros there are in that power of 10. And as we can see, in 100 there are 2 zeros, so we're going to take this decimal in 0.06 and shift it 2 times to the right to just become 6. Okay? So let's see if we have 6 over 100 as an answer choice. We do. In fact, it's D. So that's that one. On the ASVAB, you might see this as an answer choice, but that said, you also have to be comfortable simplifying fractions. So let's see what that would look like. Let's say we wanted to simplify 6 over 100. We would divide 6 as well as 100 by a common factor of 2. 6 divided by 2 is 3. 100 divided by 2 is 50. So just be prepared to simplify fractions if needed for the ASVAB. All right, number 2 says a club has 36 members. If each member donates 12 items for an auction, how many items will there be in the auction. So this is a simple case of multiplication. 36 members are each bringing 12 items, so that's going to be 36 times 12. And let's just work this out. 6 times 2 is 12, so we're going to bring down a 2, carry a 1. 3 times 2 is 6, plus 1 is 7. Before we start multiplication with this 1, we have to bring in a 0 placeholder. 1 times 6 is 6, 1 times 3 is 3. Let's add these together. 2 plus 0 is 2, 7 plus 6 is 13, so bring down a 3, carry a 1. 1 plus 3 is 4. So in total, they'll bring 432 items, which we can see is D. All right, number 3 says, what is the value of 4 over 10 plus 3 over 100? That is to say, we want to add these two fractions together. So we have 4 over 10 plus 3 over 100. Well, if you haven't worked with fractions in a long time, you may not remember that in order to add fractions, those fractions have to have the same denominators or bases. In 4 over 10, we can see our denominators 10, and in 3 over 100, we can see our denominators 100. In order to proceed, we have to rewrite these fractions such that they have the same denominators. And it's actually pretty easy to do. I can simply take this 10 and multiply it by 10, and 10 by 10 would be 100. So we can see that if we multiply this denominator by 10, we'll have the same base as 3 over 100. That said, you have to keep proportionality when you do this. So if you multiply its denominator by 10, you also have to do that to the numerator. 10 times 4 is 40. Okay, and now we can see that 3 over 100 has the same denominator as this one, so we're just going to copy this one down as is. Let's add these together, and this is how you add these. You wouldn't do 100 plus 100. The denominator stays the same, and you add the numerator, so this becomes 40 plus 3. 40 plus 3, of course, is 43 over 100. Again, if possible, we would attempt to simplify this, but that's not going to be necessary. We can see the correct answers right there. It's A. All right, so number 4 says a conference planner has put together 280 binders for attendees and another 31 binders for presenters. How many total binders did the planner put together for attendees and presenters? So this is simple addition. We have 280 plus 31. 0 plus 1 is 1. 8 plus 3 is 8, 9, 10, 11. So we're going to drop down a 1 and carry a 1. And 2 plus 1 is 3. So we can see that this one is going to be C, 311. All right. Number 5 says a store stocked 150 cans of popcorn for a weekend sale. That weekend, 72 cans sold. What percent of the cans of popcorn stock were sold that weekend? So we can express this as a fraction, notably as 72 over 150. And this says 72 of the 150 cans of popcorn sold over the weekend. And we can convert this fraction to a decimal by performing long division. Again, we can read this as 72 divided by 150. That said, if we look at our answer choices for this problem, we can see that they aren't very similar. We have 2%, 5%, 48%, and 72%. Well, half of 150 is 75. So 75 over 150 would be exactly 50%. 72 over 150 is very close to 75 over 150. So in light of the fact that the answer choices are very spaced out, logically speaking, we can confidently say C is going to be the correct answer. That said, let's say we couldn't use the mental math trick I just showed you to figure this one out, and we actually had to perform the long division. Well, prior to doing this long division, I'm going to simplify this fraction as much as possible. That is to say, I'm going to look to divide 72 and 150 by a common factor to reduce the size of these numbers. Well, I know 72 and 150 are both divisible by 3. 15 divided by 3 is 5, and just tack on that extra 0. So 150 divided by 3 is 50. Likewise, 72 divided by 3 is very easy to do mentally. 7 divided by 3 is 2. We have 1 left over, so that becomes 12 divided by 3, which is going to be 4. All right, and we can actually reduce 24 over 50 even more by dividing 24 by 2 as well as 50 by 2. 24 divided by 2 is 12. 50 divided by 2 is 25. Okay, now that we've reduced or simplified this fraction as much as possible, let's go ahead and perform the long division. We have 12 divided by 25. Okay, and now we're asking ourselves, how many times does 25 go into 1? It doesn't. How many times does 25 go into 12? It doesn't. So in light of that, we're going to have to bring a decimal here and a 0 placeholder. Once we add that decimal, we have to bring it up right here. And the question becomes, how many times does 25 go into 120? And again, we can now disregard this decimal because we accounted for it in our answer. And again, 25 into 120. Well, 25 times 4 would be 100, whereas 25 times 5 would be 125. So this is going to be 4. Again, 4 times 25 is 100. 120 minus 100 is going to be 20. And we have a free 0 that we can technically bring down. Now the question is, how many times does 25 go into 200? Well, 25 goes into 100 4 times. Therefore, 25 goes into 200 8 times. 25 times 8 is going to be 200. 200 minus 200 is 0. So we can see that this is 0.48, which is the same as 48%. Okay, so that's that one. Let's go ahead and move on. Number 6 says, what number in the list above has the greatest value? Okay, so right off the bat, we should realize that numbers such as 0.199 are going to be very small since they have no whole value here. So this isn't it. 10 over 12. 10 over 12 is very easy to reduce. If I divide 10 by 2 and 12 by 2, this is 5 over 6. This isn't even greater than 1. Again, if this was 1, it would be 6 over 6. So this is less than 1. We have 2.28, which is greater than 1, so it's greater than both of these. But that said, we have this 8/3, and we want to figure out if 8/3 is bigger than 2.28. So again, we have 8/3, and how can we compare this to this decimal? Well, we can perform long division to convert this fraction into a decimal. That is to say, we can do 8 divided by 3. And now we're asking ourselves, how many times does 3 go into 8 without going over? That's going to be 2 times, given that 2 times 3 is 6, and 8 minus 6 is 2. Again, we can write a decimal and 0 placeholders over here, and we can put as many zeros as we think we're going to need. Once we add that decimal, we bring it up right here, and we can drop down one of our free zeros. And the question becomes, how many times does 3 go into 20 without going over? Well, 3 goes into 20 6 times without going over, given that 3 times 6 is 18. So right away, we can see that 8 over 3 is 2.6 something. Again, I didn't work this out fully because I have enough information to know that 2.6 something is bigger than 2.28. So in other words, 8 over 3 is the biggest, the number with the greatest value of these 4 here. So that's that one. All right, number 7 says, if Manuel deposits 25% of $130 into a savings account, what is the amount of his deposit? So in other words, we want to figure out what 25% of 130 is. And this right here tells you exactly what to do. 25% in decimal form is 0.25. In mathematics, of means multiply. And I have a video in which I discuss that. And then we just 25%, 0.25 in decimal form of multiply, and then 130. Okay? So to figure out what 25% of 130 is, you take 0.25 and you multiply it by 130. Let's go ahead and do that over here. And as you can see, we're multiplying a whole number by a decimal. To make this math a little bit easier, let's get rid of this decimal by shifting it 2 places to the right. So this becomes 130 times 25, albeit with 2 decimals to shift back into the left when we're done. Again, I move those decimals to the right here to get rid of them. That said, once I do the arithmetic without the decimals, I'll shift them back into the left. So we have 0 times 5, which is 0. 3 times 5, which is 15, so we're going to drop down a 5 and carry a 1. 1 times 5 is 5 plus 1 is 6. Before we start multiplication with this 2, we have to bring in a 0. 2 times 0 is 0. 2 times 3 is 6. 1 times 2 is 2. Let's add these together. 0 plus 0 is 0. 5 plus 0 is 5. 6 plus 6 is 12. Carry a 1. 2 plus 1 is 3. Let's bring those 2 decimals back into the left now. 1, 2. So we can see that 25% of 130 is equivalent to 3250, which is C. Okay. All right, number 8 says, what is 1,582 plus 761? Again, just some simple math here. 1,582 plus 761. 2 plus 1 is 3. 8 plus 6 is 14, so we're going to have to carry a 1. 7 plus 5 is, well, this is technically 7 plus 6, so we know that's going to be 13. Carry a 1. 1 plus 1 is 2. So we can see this is 2,343, which is D. Okay, so that's that one. All right, number 9 says Yao Ming is making cookies. Each batch of cookies uses 3 eggs. If Yao Ming has 20 eggs, and assuming he has enough of the other ingredients to make cookies, what is the greatest number of batches that he can make? So in other words, what is 20 divided by 3? So that's going to be 20 divided by 3. 3 goes into 20 6 times without going over, given that 3 times 6 is 18. 20 minus 18 is 2. Again, we have a free decimal we can bring down as long as we add a decimal here and here. And the question becomes, how many times does 3 go into 20? That's 6 times. And right now we have enough to answer this question. He can make 6.6 batches. That is to say, he can make 6 full batches and 0.6 of another batch. This question wants to know what the greatest number of full batches he can make with those 20 eggs is. And that, of course, is going to be 6. Okay? All right, number 10 says, what is the value of 3.85 plus 0.004 plus 0.117? So in other words, we want to add these 3 decimals together. When I have to add decimals like this together, I'm going to do it vertically like this. 3.85. I'm going to line these numbers up such that the decimal places are in line. So I have 0.004, and then finally I have 0.117. In case you haven't done this simple arithmetic in a long time, you might be saying to yourself, well, what do I do about this blank space here? Well, whenever you have a blank space, just throw in a 0, okay? So with that out of the way, we can simply add these up, and likewise, we can go ahead and just drop down this decimal in place. It's not going to move anywhere since we're just doing simple addition here. 7 plus 4 is going to be 7, 8, 9, 10, 11. So drop down a 1. Carry a 1. 5 plus 1 is 6, plus 1 is 7. 8 plus 1 is 9. And 3 plus nothing is 3. So we can see that the answer to this one is 3.971. Okay. Number 11 says, which of the following is equivalent to 8 over 25? So as we've seen in this video already, to write a fraction as a decimal, we take that fraction and we treat it like long division. Again, fractions can be read as fractions, 8 over 25, or we could read this as long division by reading it as 8 divided by 25. Okay? And now we're just working on some long division here. We're asking ourselves, how many times does 25 go into 8? It doesn't. So I'm going to have to add a decimal and a 0 placeholder here. And as a matter of fact, I'm going to add a couple 0 placeholders in case we need them. Again, let me just clarify what I'm doing here. 8 can be written as 8.00000 with however many zeros you want or need to perform long division. So just bear in mind, 8 is the same as 8.0000 all the way to infinity. Okay, so now the question becomes, and before we proceed, let's bring that decimal up right here. And now we can disregard the decimal inside the division bracket since we accounted for it above the division bracket in our answer. Okay, and we can place a 0 here since 25 did not go into 8 any times. Now the question is, how many times does 25 go into 80 without going over? Well, 25 times 3 is 75, whereas 25 times 4 is 100. So this is going to be 3. Again, 25 times 3 is 75. 80 minus 75 is 5, and we can bring down one of our 0 placeholders that we put up there. 25 goes into 50 2 times without going over. 25 times 2 is 50. So we can see we have 0 now. This 0 tells us we can stop performing this long division. There's going to be no remainder. And our answer is 0.32, which is B. Okay, and I do have a video on long division if you need some more help with that. All right, number 12 says, what is the remainder when 599 is divided by 9? So that's going to look like this in terms of long division. And let's just go ahead and work this out. To start, we're going to ask ourselves, how many times does 9 go into 5? It doesn't. How many times does 9 go into 59 without going over? Well, 9 times 5 is 45, whereas 9 times 6 is 54. 9 times 7 would be 63. So this is going to be 6 times. Again, 9 times 6 is 54. So we're going to subtract 54 here. 59 minus 54 is going to be 5. And we can drop down this 9 again. Now the question is, how many times does 9 go into 59? Well, we just saw that was 6. 9 times 6 is 54. 59 minus 54 is 5. Again, if we wanted to, we can write this as a decimal and put in 0 placeholders. But again, we want to know what the remainder is. And now that we've hit this point where we can't continue without adding those zeros and that decimal, this is our remainder. So technically, this is 66 and 5/9 time, where 5 is our remainder. So the answer to this one is B, 5. Okay, so that's that one. All right, number 13 says a machine is currently set to feed at a rate of 5.921 inches per minute. The machinist changes this setting to be 6.088 inches per minute. By how much did the machinist increase the feed rate? So for this one, it's going to be a simple case of subtraction. Specifically, we're going to take 6.088 and subtract that by 5.921. As we did when we added decimals, we're going to take this decimal and just drop it down in place. And now we're just going to work this out like normal subtraction. 8 minus 1 is 7. 8 minus 2 is 6. 0 minus 9 we can't do, so we have to come over here and borrow. This becomes 5, and this becomes 10 now. 10 minus 9 is 1, and 5 minus 5 is 0. So we can see that if our math's right, the machinist increased the rate of feed by 0.167 inches per minute. Okay, so just a simple case involving the subtraction of decimals there. All right, number 14 says 0.075, 0.75%, 3/4. Which of the following correctly orders the values above from least to greatest? Okay, so since all these are in decimal form, let's go ahead and quickly convert them all to decimal form. 0.075 is in decimal form. 3/4 is very easy to convert to a decimal. Again, you should know that 3/4 is the same as 0.75. So again, this is 0.75. This one's already in decimal form, and this one looks like it's in decimal form, but we have this percent symbol hanging out there. So in order to convert 0.75% to a decimal, we're going to take 0.75 and we're going to divide it by 100. And as we previously saw in this video, when we multiplied a decimal by a power of 10, we shifted its decimal place to the right according to how many zeros there were in the power of 10. Because we're dividing a decimal by a power of 10, we're going to shift its decimal to the left according to how many zeros there are in the power of 10. In 100, there are 2 zeros, so we're going to take this decimal in 0.75 and shift it 2 times to the left, add in 0 placeholders. So 0.75 over 100 is the same as 0.0075. So in other words, let me put that over here as well. In other words, we have 0.75% being the smallest. After that, we have 0.075. And then finally, we have 3/4. So let's look for this order. Of course, that's going to be answer choice A. All right, so that's that one. All right, number 15 says, what is the value of 2.84 times 3.9? So we're going to do 2.84 times 3.9. That is to say, we're going to multiply 2 decimals by each other. And this, as it happens, is pretty easy to do. The very first thing we're going to do is shift the decimal in 0.284 as well as 3.9 to the right, such that we rewrite 2.84 as well as 3.9 as whole numbers. So we're going to take this decimal and shift it 2 times to the right. I'm going to take note of that, and that becomes 284. And in 3.9, we're going to have to shift its decimal place 1 time to the right to rewrite that as 39. So in total, we shifted these decimal places 2 plus 1 are 3 places to the right. So once we do this arithmetic without the decimal places, we'll shift them back into the left. So 4 times 9 is going to be 36, carry a 3. 8 times 9 is 72, 73, 74, 75, bring down a 5, carry a 7. 9 times 2 is 18, 19, 20, 21, 22, 23, 24, 25. Okay, so that's the first iteration of multiplication. Before we start multiplication with this 3, we have to bring in a 0 placeholder. 3 times 4 is 12, so we're going to have to carry a 1. 8 times 3 is 24, plus 1 is 25, so we're going to have to carry a 2. 2 times 3 is 6, plus 2 is 8. Let's add these together. 0 plus 6 is 6. 5 plus 2 is 7. 5 plus 5 is 10, so we bring down a 0 and carry a 1. 8 plus 2 is 10, plus 1 is 11. Bring our 3 decimals back into the left. 1, 2, 3. And we can see that this is 11.076, which is B. Okay. And if you wanted to check your answer via estimation, we can round this to 3. We can round this to 4. 3 times 4 is about 12. So 2.8, which is a little less than 3, times 3.9, which is a little less than 4. It's going to be a little less than 12, which is what we have right here. Okay, so that's that one. All right, number 16 says, what is 0.8637 rounded to the nearest hundredth? So we have 0.8637. We want to round it to the nearest hundredth. So first we have to identify where the hundredths place is in this decimal. This 8 is in the tens place. This 6 is in the hundredths place. This 3 is in the thousands place, and so on and so forth. So if we want to round this one to the nearest hundredth, we're looking at this 6 right here. More specifically, to round, you look to the number that's to the right, and if it's 5 or greater, you round up. If it's 4 or below, you keep that number the same. So in this case, we have a 3 to the right of 6, so this is just going to be 0.86, okay, which is going to be answer choice A. All right, number 17 says 60% of what number is equal to 30? Now these questions trip people up a lot because they get stuck in trying to analyze the question. The question tells you exactly what operations to perform. Again, as we saw previously, 60% is the same as 0.6. Of in math means multiply, so this is multiply. What number? Well, when you have an unknown number in math, you can call it x. An unknown is equal to 30. So let's go ahead and rewrite this down here. 0.6 times x, which is the same as 0.6x, equals 30. Now we're just solving for x, so we're going to divide both sides by 0.6 to get x by itself. This is going to cross out, leaving you with x over here. And this question becomes, what is 30 divided by 0.6? Now this may be tricky because we have a decimal and a whole number, and we're doing division. The key to doing division involving decimals is this. If the decimal's inside the division bracket, you don't have to make any adjustments whatsoever. That said, if the decimal's outside the division bracket, and it is in this case, you have to take that decimal and 0.6 and shift it to the right such that you get rid of the decimal. And likewise, you have to add a decimal here and shift that one time to the right as well. So again, we're trying to get rid of that decimal in 0.6. To make it 6, we shift its decimal place one time to the right, and we do a corresponding number of times here. So in reality, this is... All right, now the question is, how many times does 6 go into 3? It doesn't. How many times does 6 go into 30? Well, 6 goes into 30 5 times without going over. Therefore, 6 is going to go into 350 times without going over. 6 times 50 is 300 with no remainder. So the answer to this one is 50. Okay, so that's that one. All right, number 18 says if 4/3 divided by 1/6 equals p, then the value of p is between which of the following pairs of numbers? So let's just copy down what we have here. We have 4/3 divided by 1/6, and we know this, according to the problem, equals p. That is to say, we want to do 4/3 divided by 1/6. We want to divide these two fractions. In case you haven't seen that in a while, you divide fractions by following the algorithm keep, change, flip. That is to say, you keep this first fraction the same. So we're going to keep 4/3 the same. We're going to change our sign from division to multiplication. That's C, change. And then we're going to flip this second fraction. So instead of being 1/6, it's going to be 6/3. over 1. And now, instead of doing division, keep change flip enables us to do multiplication. And when you multiply fractions, you just multiply straight across. In other words, this becomes 4 times 6, which is 24, and 3 times 1, which is just 3. 24 divided by 3, of course, is 8. So we can see that 4/3 divided by 1/6 is 8. So this is 8 equals P. And of course, 8 is between 7 and 9. So the answer to this one is D. All right, so again, just a test of your ability to divide fractions there. Number 19 says, which of the following inequalities is true? And we can see we're comparing all these fractions with one another. So this is going to be a great test of our knowledge of fractions as well as decimals, as you'll see shortly. So this first one says compare 3/4 and 5/7. So 3/4 you should know from prior experience is going to be 0.75, and we want to know if that's less than 5/7. Well, you can convert fractions to decimals very quickly by treating them as long division, notably by reading this as 5 divided by 7. Let's work this out. We start by asking ourselves how many times does 7 go into 5? It doesn't, so in light of that we have to put a decimal here. We'll tack on some 0 placeholders, and likewise we have to bring this decimal up in place. Again, 5 didn't go into 7, so we can put a 0 here if we really want to. Now the question is, how many times does 7 go into 50 without going over? That's going to be 7 times, given that 7 times 7 is 49. 50 minus 49 is 1, and we drop down this 0. How many times does 7 go into 10 without going over? That's 1 time, given that 7 times 1 is 7. And we're going to stop right there. We know that 5 over 7 is approximately 0.71. Is 0.71 greater than 0.75? It's not, so we're done there. For B, you can see we have 2/3 greater than 5/6. So instead of converting these to decimals, this one's actually pretty easy to work out a different way. Again, let's make these denominators the same. 3 is a factor of 6, so to make 3 6, we can multiply it by 2. We're going to do that to its numerator. So 2 times 2 is 4. 2 times 3 is 6. This is 4/6 is greater than 5/6. Is 4/6 greater than 5/6? It's not, so we know this one's not true. Let's take a look at this one. We have 5/8 greater than 6/10. Well, let's think about 6/10 for a minute. We have 6 divided by 10. As we've seen in this video, when we multiply or divide by powers of 10, it just prompts us to shift our decimal left or right. And in 6, technically there's a decimal right here, although it's not expressed since we're just writing the whole number 6. But that said, we have 6 divided by a power of 10, which has 1 0. So that's going to prompt us to move the decimal one place to the left. So 6 over 10 is the same as 0.6. So we have 0.6 as the equivalent of 6/10. As far as 5/8 go, let's go ahead and convert this one to a decimal as well. Again, this is 5 divided by 8. And the question becomes, how many times does 8 go into 5 without going over? It doesn't, so we're going to add a decimal here and a couple 0 placeholders as needed. And likewise, we're going to bring up our decimal right there. The question becomes, how many times does 8 go into 50 without going over? Well, 8 times 7 is 56, whereas 8 times 6 is 48. So this is going to be 6. 8 times 6 is 48. 50 minus 48 is 2. Drop down this 0. How many times does 8 go into 20 without going over? That's going to be 2 times, given that 8 times 2 is 16. And right away we can see that 5/8 is going to be 6.2 something. As a matter of fact, it's 6.25. And this is a true statement. 6.25 is greater than zero point 0.6. So this one is the true statement. All right, so that's that one. All right, so I'm not going to do number 20. It's not really pertinent for the ASVAB, so that is it for this video. I hope you found it helpful. As I mentioned at the beginning of the video, these questions are very simple, and they're going to mirror the types of questions you're going to see very early on in the ASVAB since it's a computer adaptive test. If you like the content I'm creating, please consider subscribing to my channel. And as always, you're more than welcome to leave feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose.
こんにちは。